Look up into the night sky, and one star has always stood out, not because it's the brightest, but because it's distinct, red, and ominously flickering like a celestial warning light. That star is Betelgeuse, a red supergiant that has fascinated humanity for thousands of years. But to truly appreciate its majesty, we must first look inward, toward the star we know best, the Sun. To us Earthlings, the Sun is more than just a light in the sky. It's the furnace of life, the giver of warmth, the orchestrator of our days and seasons. At a staggering 1.4 million kilometers wide, it contains 99.8% of all the mass in our solar system. Its gravitational pull holds planets, moons, asteroids, and comets in their dance. Its core fuses hydrogen into helium, releasing energy that takes thousands of years to travel to the surface and just 8 minutes to reach Earth. The Sun's surface blazes at 5,500 degrees Celsius, and its corona, the outer atmosphere visible during solar eclipses, can reach over 1,000,000 degrees. We often see the Sun as the very definition of grandeur. But that perception changes when we meet Betelgeuse. Located over 600 light-years away in the constellation Orion, Betelgeuse is not just big, it is mind-bendingly enormous. Betelgeuse is a red supergiant, one of the largest types of stars in the known universe. If our Sun were the size of a coin, Betelgeuse would be as large as a hot air balloon. If it were placed at the center of our solar system, it would stretch past the orbits of Mercury, Venus, Earth, Mars, and possibly even reach Jupiter. Its radius is estimated to be more than 1,000 times that of the Sun. It's so large that over 1 billion suns could fit inside it. Yet Betelgeuse is not just massive, it's unstable. It's a dying star, burning through its fuel at an extraordinary rate, and undergoing internal convulsions that cause it to swell and contract over periods of hundreds of days. These pulsations are not subtle. The star's brightness visibly changes over time, dimming and brightening in a dramatic cycle that has mystified astronomers for centuries. In late 2019 and early 2020, Betelgeuse dimmed so significantly that it sparked global excitement and alarm in the scientific community. Was this the final signal that Betelgeuse was about to explode in a supernova? A supernova is no small event, it's one of the most powerful forces in the universe. When a red supergiant like Betelgeuse reaches the end of its life, gravity eventually overwhelms the pressure from nuclear fusion in its core. The star collapses inward in a matter of seconds and then violently rebounds, releasing an explosion that can briefly outshine an entire galaxy. If Betelgeuse were to explode, it wouldn't pose any direct danger to Earth, but the sight would be breathtaking. For weeks, possibly months, Betelgeuse would be visible even during the day. At night, it might cast shadows. The spectacle would be unlike anything seen in human history. But Betelgeuse didn't explode, at least not yet. Scientists determined that the 2019-2020 dimming event, now dubbed the Great Dimming, was likely caused by a giant surface eruption that ejected a massive cloud of stellar material. This cloud temporarily obscured our view of the star, causing it to dim drastically from our perspective. But the incident raised more questions than it answered. What exactly caused such a dramatic ejection? Could more be on the way? And what does this tell us about the inner workings of dying stars? That's where the James Webb Space Telescope enters the story. Launched with the most sensitive infrared instruments ever built, the JWST is humanity's newest eye into the deepest, coldest, and oldest corners of the universe. Unlike telescopes on Earth or even the Hubble Space Telescope, the James Webb can pierce through dust and gas to reveal stellar activity hidden in visible light. It's been tasked with an ambitious goal: to unlock the secrets of stars like Betelgeuse, not only to monitor their surface activity, but to understand the final stages of their evolution with unprecedented detail. Recent JWST observations have given us extraordinary insights. We've seen massive plumes of gas and dust emanating from Betelgeuse, confirming theories that the star periodically sheds its outer layers in catastrophic bursts. These eruptions could be tied to internal shock waves, massive ripples of energy generated by unstable fusion deep within the core. In essence, Betelgeuse is not just pulsating, it's convulsing with the chaos of approaching death. But how close is that final explosion? A few years? 1,000 years? In astronomical terms, both are just a blink. And here's the paradox. While Betelgeuse is clearly in the late stages of stellar life, predicting when it will go supernova is incredibly difficult. A star this massive and chaotic can remain in its death throes for a very long time. Yet every flicker and dimming episode brings us closer to understanding the forces at play. This is not just about Betelgeuse. Studying this red supergiant could reveal universal patterns about how massive stars live and die, patterns that may help us understand the origins of heavy elements like gold and uranium, which are forged in the crucibles of exploding stars. It could also help us predict future supernovae elsewhere in the galaxy, and how such events might affect nearby planetary systems. As we begin to peel back the layers of Betelgeuse's turbulent personality, a bigger picture begins to form. The universe is a place of both immense violence and sublime beauty. Betelgeuse is a symbol of both, a ticking cosmic time bomb, and a glowing monument to the incredible power of stellar evolution. So, the next time you look up at Orion on a clear night, find Betelgeuse, the reddish star marking the hunter's shoulder. You're not just looking at a star. You're staring into the final act of a cosmic giant. One day, it will explode in spectacular fashion, and the universe will never be the same. And with every passing year, we edge closer to witnessing that unforgettable moment. When the James Webb Space Telescope was launched, it carried the hopes of astronomers, physicists, and dreamers alike. Its mission was ambitious, to look further and deeper than ever before, to capture the first light of the earliest galaxies, peer into the hearts of star-forming regions, and uncover secrets hidden in cosmic dust. But few expected that one of its early surprises would come from a star that's practically in our galactic neighborhood, Betelgeuse. In mid-2023, JWST turned its powerful infrared eye toward this legendary red supergiant. The goal? To study its behavior in a way no telescope ever had. Webb's instruments can detect wavelengths of light that are invisible to human eyes and even to many other space telescopes. That means it can see through the thick clouds of gas and dust that Betelgeuse frequently ejects, material that obscures its surface in visible light, but glows faintly in the infrared. And what JWST found was nothing short of astonishing. Betelgeuse isn't just dimming and brightening in predictable cycles. It's erupting, violently and chaotically. The telescope detected giant arcs of gas and dust arcing away from the star, stretching trillions of kilometers into space. These arcs aren't calm waves. They're the aftermath of massive outbursts, where Betelgeuse expels vast chunks of its own atmosphere into space. Imagine a star so large and unstable that it regularly throws parts of itself off into the void, each time growing more unbalanced, more hollowed out, and one step closer to collapse. This isn't theoretical. One of the most dramatic findings was the confirmation that the Great Dimming of 2019-2020 was caused by such an outburst, what some scientists are now calling a surface mass ejection, similar in concept to a solar flare, but on an almost incomprehensible scale. Betelgeuse literally blew off a piece of its outer layers, which cooled into dust and temporarily blocked our view of the star's light. The event was so massive that it likely altered the star's internal structure and convection patterns. The scale and violence of this event shocked even seasoned astronomers. The mass ejected was several 100 billion times more than in a typical solar outburst from our Sun. Imagine a storm that can alter a star's heartbeat. That's what happened here. But what truly set the scientific community abuzz was the implication. Stars in their final stages might not behave in slow, predictable ways. Instead, they might thrash violently, ejecting material in bursts, giving us warning signs that are both subtle and catastrophic. And if Betelgeuse is entering such a phase, then its timeline may be far shorter than we thought. Still, there's caution. While all signs point toward instability, this doesn't guarantee an imminent supernova. The timing remains elusive. Stars like Betelgeuse can linger in this volatile state for decades, centuries, even longer. But never before have we had tools this precise to monitor one. And now, with each observation, we're getting closer to understanding what a pre-supernova star truly looks like. Webb also revealed something else, something more poetic. The outer shells of material cast off by Betelgeuse form layered halos, like rings around a dying monarch. These structures, once invisible, now glow in Webb's data like fingerprints of past upheavals. Each ring tells a story: a previous eruption, a cooling phase, another violent shake. It's as if the star is leaving behind a cosmic diary, each chapter etched into space by explosions and radiation. These findings are more than just curiosities. They are rewriting textbooks. Until recently, scientists believed that stars gradually lose mass over time in a relatively smooth wind. Now, we see that dying stars can shed their layers in fits of fury, in sudden catastrophic bursts, sending shockwaves through space that ripple across time and distance. This matters because supernovae aren't just pretty explosions, they're creators. The calcium in your bones, the iron in your blood, the gold in your jewelry, all of it was forged in supernovae, in the deaths of stars like Betelgeuse. By studying this star's final phases, we're not just learning about its fate. We're learning about our origins, and the violent cycles that make life itself possible. So what now? Scientists continue to monitor Betelgeuse with Webb, with Hubble, and from the ground. The star pulses, flickers, and trembles, and we watch, wondering whether we'll be the lucky generation to witness its final blaze. There's an eerie thought behind this. Betelgeuse might have already exploded. Because it's over 600 light-years away, everything we see is delayed by centuries. If the supernova occurred any time in the last 600 years, we simply haven't seen it yet. The light is still on its way to Earth. One day, perhaps tomorrow, perhaps in 100 years, the skies may erupt with the arrival of that ancient signal, a celestial headline from the past, announcing the death of a giant. And when that day comes, it won't just be a scientific event. It'll be a moment of human connection, across cultures, across continents. We will all look up and witness something our species has never seen in recorded history: the death of a star with our naked eyes. Thanks to the James Webb Space Telescope, we won't just be spectators. We'll be interpreters of the light, reading the final verses of a star's long, turbulent story. And maybe, just maybe, we'll come away with a deeper appreciation for our place in the cosmos.